I'd like to start off by asking you a question about our lab topology. Now, we have some components in place that are interesting. For example, we have some storage in our lab environment. We have this server here that's acting as a DNS, Active Directory, and DHCP server. We have the vCenter server appliance that's running as a VM on ESXi1. But truth be told, if we open the kimono a little bit, each of these ESXi hosts is also virtualized. And that's how we can provide them via the cloud. So these are also effectively VMs that are running other VMs. So here's my question. When we power on the lab, behind the scenes, which one of these devices should we start off first with? Now we have some devices that we can exclude. For example, the vCenter server appliance, because it runs as a VM on this host, it can't possibly run until that host is up. So I would say that probably we want to get our storage up and running as quickly as possible, along with our Active Directory and DNS and DHCP services. And then after they have a little bit of a head start booting up, then very likely ESXi1 is going to be a high priority, and then ESXi2 and 3 can be at the same time, or they can be staggered. And then as ESXi1 fully initializes, the vCenter server boots up as well. And so for the lab topology, one of the reasons it takes sometimes 5 to 8 minutes for the whole lab to initialize and for the vSphere web client to be able to respond with the vCenter server appliance is that it might take 3 minutes for this ESXi host to boot up and initialize, and then it might take another 5 or 6 minutes for the vCenter server appliance to fully initialize. And that's why whenever you think of lab, we can think of launch at beginning, meaning launch it at the beginning of the video, and that way when you're ready to do the lab, it'll all be initialized and ready for you too. Okay, so regarding the order of things and what has to come up first, in other environments, besides just having everything virtualized like we do here in the lab, we also might have multi-tiered applications. For example, we might have a database server that needs to come online, and we want it fully initialized before we bring the web server online that's leveraging and using the database server. And then we also might have an accounting server that we want to have come online, but not until the actual web and database servers are up. So it'd be really cool if there was like an easy way, if these were all virtualized servers. It'd be amazing if there was some way we could organize them into some kind of a structure or container and then have them automatically power up in a specific order as a group. And the great news is that's exactly what a vApp is. A vApp is a logical container inside a vSphere. So let's imagine that we have a vSphere cluster, which we do. Let's imagine that DRS is enabled on that cluster, and in that cluster we create a vApp. And as part of that vApp, we could go ahead and simply park or put VMs into that vApp. And it's really easy to get VMs into this vApp container. Whenever we create a new virtual machine, whether it's creating it from scratch, or we're creating from a template, or we're cloning from another VM, or if we're creating a new virtual machine from an OVF or OVA file. And OVF stands for Open Virtualization Format. And it's a great way to package a virtual machine into a set of files that we could then distribute. So for example, if we want to take a VM or a vApp and export it to an OVF, we could then share that folder with the OVF files in it so that someone else could take that folder and those files and they could import and create a new virtual machine from those files. And the same thing is true for vApps. If we wanted to package up our 3 VMs as part of a vApp, we could export to an OVF and then we could later import from that OVF. And behind the scenes, vSphere is using OVFs all the time. But we can manually do it too by simply exporting or importing from an OVF. There's also an OVA. And OVA stands for Open Virtualization Appliance. And basically, it's a combination of the OVF files, but packaged into a single file. So you can go online, you can look for a specific appliance, download it, and then you can deploy a VM, for example, from a completely packaged, ready to go OVA. And an easy way, at least for me, to remember that is the OVF is a set of files that represent a virtual machine or a combination of virtual machines like a vApp. And an OVA is an all-in-one. Just looking at that last letter. Sort of like a zip file of everything needed all in one single file. So going back to getting devices into a vApp, anytime we have the creation process for a new VM and we specify the compute resource where we want it to run, once we have a vApp created, we simply point at that vApp, and then the VM that we're creating will automatically be inserted in that vApp container. Now, another cool thing about vApps is that, like resource pools, we can also control the reservations and limits and shares on a vApp. which is pretty handy because literally it is just a container for one or more VMs. Another benefit of the vApp is that we can also control the boot order of the VMs. So we can power on the vApp, and then through its configuration, we can say, okay, we want the database VM to come up first, and then after 120 seconds, we want the web VM to come up, and then after another 120 seconds, we want the accounting VM to come up. So in the hands-on lab, what we'll do is we'll create a new vApp. We'll walk through a couple different ways of getting a new VM into that vApp. And then we'll take a look at some of the configuration regarding the boot order for those VMs. And then I'd love for you to reinforce what we're learning together in this nugget by you doing the hands-on practice in the labs that we provided. So here in the vSphere web client, what we'll do is we'll click on the Hosts and Clusters tab, and then let's click on Cluster-2. And let's create a new vApp by right-clicking on the cluster, and from the Action menu, simply hovering over New vApp, and from the submenu, we'll simply click on New vApp. If we had an existing vApp, we could clone from one, but we don't, so we'll create a new vApp, click on Next. We'll go ahead and leave it the name of vApp, and where do we want to put this vApp? Let's go ahead and place it in the VMs folder, because at the end of the day, this is a container that's going to contain VMs. So we'll put it in the VMs folder and click on Next. And here's our opportunity regarding the vApp, controls regarding CPU and memory. So if we wanted to set up reservations, we could. If we wanted to set up limits, we could. And if we wanted to modify the default shares for this vApp, we could. And if you'll notice, these settings here regarding normal of 4,000, low of 2,000, and high of 8,000, those are the same levels that we had with our resource pools. And in this sense, it's similar where we can control the reservations and the limits and the shares for this container object, and it'll have an effect on the VMs that are part of this container. So for the reservation, let's go ahead and actually give this a couple gigahertz of reservation for this vApp. And then we'll click Next. Here's the summary, and we'll click Finish. And ta-da! Here's our vApp right there. So next, let's go ahead and create some new virtual machines and place them in that vApp. Now there's lots of ways of creating virtual machines. We could do it from a template, we could clone a machine, we could create a machine out of the library. So virtually all the traditional ways of creating a VM could be used, and we could place the VM as part of this container called a vApp. Another option, because we have the vApp in front of us, is we could right-click on the vApp, and then from the Actions menu, we could select New Virtual Machine, and then on the submenu, we can click New Virtual Machine. And this just gives us a large laundry list of options that we can use in the wizard. So we could create a new machine from scratch, deploy from a template, and so forth. And based on what we select here, the wizard will be slightly different. So for example, if we wanted to clone an existing virtual machine, we could go ahead and select that, click on Next, and it's going to ask us, hey, who are you going to clone from? Who's the source? So we'd go ahead and find a good candidate. We're going to expand USA, expand the Las Vegas data center, expand the VMs folder, and let's use VM1 as the source for the cloning. And we'll click Next. And let's name this vApp-VMA. It's asking us where we want to park this. Let's go ahead and expand USA. We'll expand the data center, and we'll go ahead and click on VMs, and then we'll click on Next. Now it's asking us about the compute resource. And if you'll notice here, we have the vApp, which is conveniently highlighted. And that's because when we started, we right-clicked on the vApp to begin with. So we're going to choose the vApp as the destination compute resource, and this vApp is getting the resources that's going to be provided to the new virtual machine from the hosts in the cluster. So with the vApp selected, we'll go ahead and click on Next. And by the way, this is the magic of getting the VM as a part of this container called the vApp. So we'll click on Next. We'll go ahead and specify that we want thin provision. Let's use the iSCSI data store. Click on Next, and then we'll click on Finish. And so this is now in the process of creating a brand new VM based on VM1. And we'll give that a moment to let that complete. And it's done. Fantastic. So we'll minimize the recent tasks. And let's go ahead and clone VM1 again. This time, instead of right-clicking on the vApp and specifying that we want to go ahead and create a new virtual machine, we can just do our normal clone from a VM. So let's right-click on VM1. From the menu, we'll go ahead and hover over Clone, and then we'll clone to Virtual Machine. We'll name this one vApp-VMB. Let's go ahead and expand the data center. Let's also select the VMs folder and click Next. And then here, instead of putting it in the cluster, we'll expand cluster 2, and there's our vApp. So we'll select the vApp as the compute resource, and that's what's going to put this new VM that we're creating into that vApp. So with vApps selected, we'll click on Next. We'll specify that we want to use thin provisioning, iSCSI data store, click Next. We're not going to customize anything at the moment on this VM, nor are we going to power it on, and we'll click on Next. And then we'll click on Finish, and we'll let that cook for a little bit. So if we go down to Recent Tasks, it's creating a new virtual machine, and while that's doing that, let's go ahead and clone another VM, and we'll put 3 VMs into that vApp. So let's right-click on VM2, we'll hover over Clone, and then click Clone to Virtual Machine. We'll call this one vApp-VMC. We'll go ahead and specify the VMs folder once again. Click on Next. We'll expand the cluster, cluster 2. Click on the vApp as the compute resource that we want to use. Click on Next. We'll make sure we're using thin provisioning, using the iSCSI data store. Click on Next. And we're not going to customize, nor are we going to power it on, and click on Next. Here's our summary, and we'll click on Finish. So there's our 3 VMs that are contained in this vApp. And if we click on Recent Tasks, we'll just make sure that final VM gets created. So it's just finishing off by cloning from VM2. And when it's done, we'll go take a look at the properties of the vApp. And it's done! Hooray! Okay, so we'll minimize Recent Tasks. And then at the cluster, before we go take a look at the properties of the vApp, at the cluster level, let's go ahead and click on Monitor, the Monitor tab. And then with Resource Reservation selected here with the CPU option selected, we can see all of the reservations and limits regarding CPU. Now, when we created our resource pool in a previous nugget and we did a resource reservation of 4 gigs, that shows up as used, just because that resource pool exists. This VM down here, VPM with CPU reservation with a 2 gigahertz reservation, that's not reflected up here right now because this VM is not powered on. And very similar to a single VM with a reservation, this vApp with its reservation of 2 gigs is also not yet reflected up here in the used reservation because it is not at the moment powered on. So once we power on the vApp, the reservations for the cluster are going to show as 6 gigahertz of CPU, which will reduce the available reservations for other devices that have reservations associated with them. For example, another VM or another vApp that has a reservation in the cluster. So let's click on the vApp. And if we want to configure the vApp, we simply right-click on it and click on Edit Settings. Also right here, if we wanted to export this vApp, we can simply export it as an OVF template. And then we could take those files and we could place it on another system, or at a later date we could re-import it. And if we export the vApp, we're really exporting the vApp and all the VMs that are making it up at this moment, including their hard drives. So what we want to do is let's click on Edit Settings regarding the vApp. And here we can modify the CPU resources. There's our reservation of 2 gigahertz. We can configure the memory resources with the shares and reservations and limits. And we can do other things such as modify the start order of the VMs. So if we click under Authoring, if we expand the start order, it has these VMs in these 3 different groups. And if we click on, for example, vApp VMA, it's going to show us the startup sequence, which says when 120 seconds have elapsed, or if we click this little checkbox here, put a check in it, when VM tools are ready. So what I'm going to do for group 1 is I'm going to specify a wait time of 15 seconds, and then press Enter, and then click on the vApp VMB, which is in group 2. And with that selected, we'll go ahead and we'll type in 15 there and press Enter. And then in group 3, we have vApp VMC, and let's put 15 seconds there as well. It also states here that all entities in the same group are started before proceeding to the next group. So if we wanted, for example, just 2 groups, we could highlight vApp VMC, use the up arrow key, and simply put it in group 2, which means that VMA would start, and then after a short delay, we'd have VMB and VMC start. So for the demonstration, let's go ahead and push back VMC down in group 3. It also states that shutdown occurs in the reverse order. So if it brings them up A, B, C, in theory it should shut them down as C, B, and then A. So with that set, we'll click OK. And with this vApp selected, we could go ahead and right-click and power it on, or we could use this icon up here to power on the vApp. Let's do it. So we'll power on the vApp, and just for fun, let's go down to Recent Tasks and see if it does it in order for us. So there we go. So VMA is being started. Fantastic. And after a few seconds, we should see VMB. Then after a few more seconds, followed by VMC. So there's VMB. So I'm rooting for VMC. There it is. And now VMC is being powered on. And now that that third VM is up and available, the Start vApp task is considered complete. So we'll minimize the recent tasks, and then we can actually open up consoles to these VMs as well. So if we right click on VMA, and from the menu select Open Console, I'll also take my browser out of full screen by using F11. So here's the tab for VMA, and we could open up consoles for the other ones as well. So with the reservation and not a lot of contention for CPU in the cluster, if we ran a utility, for example, we'll click on the mouse, go to the terminal emulator, and we'll type in GLX gears as something that will chew up some CPU, the results are going to be pretty good because none of the other VMs are doing much of any work. And even if they were, there's a lot of CPU resources that are available from the ESXi host. It has multiple processors and multiple cores, and each of these VMs that we set up is simply using one processor, one virtual processor. So as an example of how the vApp also can be used to limit the resources used by the VMs in that vApp, let's go ahead back to the vSphere web client. Let's go ahead and power off the vApp. We'll simply right click on the vApp, and from the power menu specify that we want to go ahead and shut down. That'll do a graceful shutdown of the VMs in that vApp. We'll click on yes to confirm. And then while those VMs in that vApp are going down, let's right click on the vApp. And from the action menu, we'll click on edit settings of the vApp. Let's go to CPU resources. And instead of doing a reservation of 2 gigahertz, we'll go ahead and put that back to 0, the default. And instead, let's set up a limit. And let's set up the limit as 2000. And I'm hesitating just a little bit because the vApp has to boot up all 3 VMs, which is going to take quite a bit of CPU. So even though it's staggering the boot up by 15 seconds for each VM, if we limit the entire vApp to 2 gigahertz of CPU from the host, it's going to slow down the process. But that's okay. We can at least verify that it is working. So we'll click on OK. And then let's go ahead and we'll power on the vApp once again. So the vApp is selected on the left. We'll use the power on icon to start them up. And then we'll give it a moment. We can look at recent tasks to see the boot order. Also, while we're here, we can also see the power off. It powered them off as VMC, B, A, in the reverse order as it said it would. All right, so as that completes, let's go ahead and let's open up a console to VMA. So we'll right click on VMA and click on Open Console. And I'll close the old console that we had for it a moment ago. And now with a limit at the vApp level, let's go ahead and click on the mouse. Click on Terminal Emulator for VMA, and let's do GLX gears again. So previously, when there was no limit in place on this vApp, this VM, who's requesting resources, wasn't being constrained regarding CPU, but now it is. So if you notice, the actual frames per second is going to be less, or it is less, and the gears are also moving significantly slower. And if we went back to the vSphere web client, and we clicked back on the cluster, and then we clicked on the VMs tab right here, there's a button here for our vApps, so we can see our vApps and what their settings are. And if we click on virtual machines, it shows us the individual virtual machines, including the 3 that are part of that vApp. And I'm going to click on refresh to look at the latest information. And what we'll discover is that these 3 VMs as part of that vApp will never exceed that 2 gigahertz limit that we just set up. And as a result, the performance is going to be less than if they had no limit in place. So I'm going to go ahead and power off the vApp by simply right-clicking on it. And from the power option here, select Shutdown from the submenu. Click on Yes. And now, my friend, it is your turn to practice in creating and verifying the use of a vApp inside of vSphere. So enjoy the lab, and I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.